provision devices is a bit more tricky. So it definitely doesn't take minutes to set up that solution, while LPWAN does. With LPWAN, you set up the network if you wish. So there is all sorts of devices you can use for that. Like on Sigfox, for example, they sell the microbase station, which expands their network. So while they have their own network, you can expand it where you need it using the microbase station. There's also indoor gateways, like Paul was using now on his demo, like this. And there is also, of course, the solar gateways, which make deployment very quickly. And I did have some experience with that, as Paul mentioned. There is this industrial gateway, which is on the right, which is a big box. You can just ship anywhere in the world. You set it up in about 15 minutes, and it goes online. So you've got a live LoRaWAN network for about 5 kilometers around. There is a 3-meter pole, makes deployments really quick. In terms of device to cloud, so this means what to use to send data to the cloud. There are many options, many open source options. I think everyone except Sigfox on here are basically open source solutions, which just take the data from the device and transform it into MQTT or HTTP callbacks. So it makes it really easy to integrate with your cloud application. So I'd say that from the cloud, from the network side, I think things are looking very good. We can now deploy networks very quickly, no problem. We get data in very easy ways. This can be connected to AWS IoT, Azure IoT, all sorts of platforms. So that you have lots of choice for that. And I don't think there is any, you can't really improve on that much more. However, on device side, this is a very different story. So usually when you're creating an IoT device, from my experience, usually start with like a proof of concept. This is can be on a breadboard or a small solderless board. You buy some dev kit, like Paul was also using in his solar gateway. You buy some sensor shields or modules, and you kind of wire all them up with wires. It looks a bit ugly, so this is something you can't really ship to a client for testing, for example, but it gives you that confidence that at least in theory it will work. Usually you do about 1 to 10 units of this just to prove the concept, run it for a few days, tweak any problems, and kind of solve the problem. Once you've done that, usually you go into a prototype stage. This is kind of involves designing a custom PCB. Usually you get the module from the manufacturer, which is usually cheaper and makes things look more like robust so they don't fall off. You design the board, like I was saying. This is sometimes costly if you don't design boards yourself. You have to pay someone to do that. You have to pay a manufacturer to produce the PCB. You have to wait a long time for everything to happen, and you've got to pray that it all works first time. Usually it doesn't. It takes maybe 1 to 3 steps at least to get it working. But usually I think a prototype stage is reasonable to say will be about 100 units. So if you're doing a tracker, you'll do 100 units with a custom PCB, and you'd send them to your good friends or your best clients and have them try it for your own. And then about 9 months later, usually 9 months, I'm saying 9 months is kind of a rough time, sometimes more, sometimes a bit less. But the idea is you go into production, so you go into a factory. I have a nice video here, which I'll have to share some other way. But this is kind of the typical idea that currently devices are made. And if you think about it in software terms, this is kind of a waterfall model. So while you were doing a prototype initially, at least to get your concept right, after that step, it's basically waterfall all the way down. So you do a design, you implement it, you test it, and then once it's out there, it's out there. You can't change it. And any changes will involve kind of replacing the board, which isn't great. Sometimes you have problems even after the deployment stage. So, or there's bugs that came up on the hardware itself. Like, for example, the Nordic just had a problem where people can actually download firmware from their devices. This will need an hardware change. And in a normal device, that means replacing the entire board. So it's kind of producing everything again. Very expensive and also not efficient. So really, for a long time, I've been thinking of how can we make this more agile. So hello?
Now
What's happening?
I don't know, we lost your voice on a point.
Oh, sorry. Yeah, I was muted by someone. Where were you?
No, it was just 10 seconds.
Okay, right. Yeah, so I was saying that we really want a more interactive development and also deployment stage. So the idea with Rack is that, and this is an idea it doesn't need to be Rack, you can do it yourself. This is something, for example, the microelectronica boards do. It's just more, just uses more space than Rack's solution. So the idea is you just put everything on small modules. You add very tiny connectors. This is connectors that came from the mobile phone industry. So they are standard, very low cost, high volume connectors. And then you create a baseboard, and then you just attach all the modules you need for your solution. So this means you can change the sensors. You can add a GPS sensor, or you can add accelerometers, or anything you want to the main board. You can add your CPU or radio module to the board, and then any extra I/O you need there as well. This means that once you do your design and you've tested your device, you do your firmware, you are ready to go into production, because these are all production devices, so they're all production modules. There's no like a development kit involved. This is the final modules are the development kit. And the cost that it adds by adding all these little boards and connectors isn't too bad. It's less than $2 for the PCB plus the connector. So while you have to have a few, if you're doing like a production for 1,000 units, it's not a big change compared to possibly having to throw all the boards out. This gives you that flexibility, so you can change. So if you find out later that actually you don't want LoRa, you may want Sigfox, you can replace the CPU module with the Sigfox module and still keep all your sensors. Everything's still the same. The C certification will change very little change there, because a lot of it has already been pre-certified, and the modules are pre-certified as well. So it kind of makes the whole process much quicker. Also, the idea is that we support multiple IDE platforms. So the Arduino is very popular. Of course, it's a very it's efficient system that people love. ARMembed will be another one. Is C-based as well. But we also support things like MicroPython on some of the modules. So where there is RAM available, we can support that. On this one, for example, it's possible. We can also support CircuitPython on the Nordic boards, and also Esperino is also coming. So the idea is you can choose any of the major platforms for development you want, and use them for your device there that way. So I've got an example here. This is one of the boards on my hand. Maybe I'll share my camera now afterwards. And this is kind of the development we go through. So we start with that board. We populate it with the modules we want. We have enclosures that match the board as well, so you can just select the enclosures you need. We have a good range of them because they are mounted on a metal bracket, which we customize for each box. Then you can add the cable I/O module, for example. Then you add your battery solution. You can use any LiPo battery or a lithium battery. And then finally, you have your final product. And this is actually an actual product I developed with this solution. It's a weather station. And the only thing we had to do is take the existing board, take the existing enclosure with the solar panel even, and I added a small board with some sensors for the weather sensing, and then a metal bracket. So this was also designed by RAK, a very low cost metal bracket. And that's it. I do have a cool video I'd like to share, so I'll stop sharing this one. And I'll open a video. Yeah, this would work better on Keynote. Yeah. So let's see if I can share this.
Feel free to start asking questions on the chat. Anyone?
Okay. Okay, I hope you didn't go deaf with that video. So this is kind of the board. I've got a few examples here. So this is with different modules. And you can actually see, so I've got, this is an RS485 module. This is the board, so I'll just connect the two through that connector there. Click, done. And then if you want it to secure, so there are some screw holes, you just get your screwdriver and you do it all. You don't need to solder anything. So I think this is a great system which lets you create and evolve your design very quickly. Hope you liked it.
Nice.
And that's all. Yep.
Wow, that's awesome. Yeah, actually, some years ago I was a fan of Arduino, kind of these puzzle, hats or etc. But lately I couldn't see anything that to go on production, or at least to do some unit or something solid.
Yeah, that's
so this looks like a fantastic solution.
Yeah, so you can start with this, and then if you select your modules, you can, it's all open source hardware, so you can design your own modules using KiCad. We will provide board layouts for this. And once that's done, you just tell RAK, you press a button, and RAK makes 1,000 for you, no problem. That's kind of the idea around this.
So how do you recommend anyone from the community to get started with the Wise blocks?
So the Wise blocks are not official yet. This is coming at the end of the month. You can order already some boards already, but the software is getting ready now. We have the Arduino and we have the MicroPython. We're working on the other ones now. But if you want to try, you can just buy it off online now from the rack store. Or you can contact me if you have an interesting project. We are looking for interesting projects as well. On the pricing, I see the costs. So it depends on the module. It can be from $30 to $50, maybe that kind of price range. That's including the LoRa and BLE and maybe one sensor. So it's the hardest part is really making people understand what they can do with this and what modules they can order to try it out.
So that temperature, GPS, and LoRa that you...
Yeah, that's all covered already. Accelerometer, temperature, air quality as well, GPS, RS485, which allows us to do Modbus as well. And we have a module with op-amps as well, so you can do analog sensors with that. And we, as I was showing, we do have the LTE board. So this adds LTE and NB-IoT to the LoRa or Sigfox side on the same board. So you can just add that in. So if you find that later, I need cellular, you can add that in later. You just have to change your firmware, of course, for that. But there are more modules coming. So any kind of the idea is our clients will ask for modules, and if it's interesting for the community, we will do it. Or they can share their own modules. They can sell module for this as well. It's an open design, like I said. The connector is standard. You can buy it from DigiKey or Mouser or from China, where it's a bit cheaper there. It's a standard from Panasonic. It's a Panasonic connector. 40-pin high density. The biggest problem of making modules is perhaps it's dual-sided. So there is so the connector is on one side, and then you've got all your components on the other one. So that may be a bit tricky for some people to do. But you can order that easily on most sites. And enclosures, enclosures. We have this solar enclosure. This is our outdoor unit, so it's all IP rated, and it's got this one has a port for RS485 already, so you can connect your Modbus stuff here. We use this to monitor some inverters, solar inverters for pumps, so in some farming applications. This is the Sigfox weather station developed for Liverpool Uni, which is, I think it's very low cost for what it is. So we added the dust sensor and outdoor air quality and temperature and humidity sensing to that. But it all uses the standard platform. So if we want to change the sensors, we just replace the sensor board very easily. That's the idea. Yeah, I'll share my contact. No problem. Yeah, I mean, the idea is the community will also look into this because we'll be sharing the designs. And if you want to do it another way, yeah, you're free. As long as you use rack modules, it's okay. Any questions?
Great. More questions for Jose.
Okay.
What other cool stuff are you doing on rack?
Yeah, rack is
tell us
always
more about other stuff that you are doing.
Sure.
Not just focus on this.
No. Rack is doing a lot of things. Of course, they're working on gateways as well, which you might know. They're very popular gateways. So if Paul wants to do...
Jose?
Yeah, sorry.
Hello.
Can you hear me? Hello? Is it breaking up? Hello?
I hear you, Jose.
Okay, it's Mark then. Hello, Mark. Mark's gone.
Yeah. Yes, I can hear you. Yeah.
Okay.
So, yeah, you.
Yeah, so Rack is doing a lot on gateway side. So there is the new
UK since the
SX1302.
Brexit, yeah, the internet sucks.
Yeah.
Can you hear us now?
I can hear you. Hello? No.
Some questions on the chat, Jose, if you
Yeah,
want. Let's try to be more synchronous on that. So it's any Sigfox block at yeah, I think there is Sigfox, LoRa, and GSM, or what's the connectivity blocks on WISE block?
There is LTEM and then BIoT.
And Sigfox and LoRa?
And Sigfox and LoRa, that's right. I'll turn off my video, maybe it helps.
Okay, awesome. And so Sigfox and LoRa for the European channel, but as well, so we have people from Ecuador. I think at the beginning we saw someone saying hello from Ecuador. So that should work as well in other frequencies or channels.
Yes, of course. So we all the rack modules are supported. So that includes all the frequencies. And on Sigfox, we will support worldwide coverage as well.
Okay. Okay, great.
Yeah.
We have more questions. Antonio is asking you if the motherboard has solar LiPo charger.
Yes. Yeah, it is there.
Okay, cool.
Not super efficient. It's not like an energy harvesting chip, but it's enough to power things.
Jordi asking about the narrowband IoT module.
Yeah, I've replied.
Yeah, you already. You already replied. You are fast.
Yeah.
You can talk and write at the same time.
And so I was saying that Rack is doing SX0302 gateways now. So this is the new LoRa concentrated chip, which is maybe half the power of the old one. So if Paul wants to do some solar gateways, he should maybe get in touch with me, and we'll do something together, because this is really good for solar. If you can run, you can run a gateway with LTE in the same power envelope he's doing now.
Wow, that's great.
Yep.
Paul, are you here, by the way?
Yeah, I'm there. I've reconnected with my laptop.
Okay.
So yeah, there is this concentrator now.
Now, if you have, sorry. More questions for Paul and Jose. Actually, everything that you saw on the Paul presentation, actually he has a blog, disk91.com. So if you go there, you can see all the detail from how to build a solar LoRa gateway and all the projects that he did. Actually, one of the that I mentioned, it is $1 Sigfox tracker, right? That you actually explain how to do it, no? That anyone can do one.
Yeah.
So how that project going, by the way?
I mean, we are actually industrializing the product. So we are having building some of them from a China factory. So we have 1,000 that has been made, and we currently have. And in parallel, I'm working on the certification of the product. So it might be the first ultra-low-cost IoT device certified by Sigfox. They are currently running the certification. And I've just received the radio chamber radiation results, which is not perfect, but good enough for that product. So I'm quite happy. And now we're also running some POC with some of our customer. What we see, which is really interesting, is that more than it's a really low-cost tracker, and the first market we have in mind was for things like parcels or postal delivery to track this, and that's quite interesting in that domain. But more of the contact we have are more on inventory, in fact, because as you can, for really low cost, I mean, when we say low cost, it's about something like under $5, and so you can stick it everywhere on a different asset you have, and even if the precision is not on a centimeter or meters, you can know that an object is in that place using a local Sigfox gateway. And so you are able to trace different things in different inventories you have. So that's an interesting use case where we have different customer looking at. So we start running POC with the current version of the device. So it's quite interesting.
And what new projects are on your table?
Sorry?
Can you disclose new projects on your table?
You mean the table application for this?
No, something new. Something new that you are doing that you are still not writing about.
Okay. But the project I'm working on currently is the one I showed you when I was in the rooftop and the tracker. And one project I think about this tracker. I mean, this tracker is a one tracker I made for my company. So it's a service-based tracker with a closed source, basically. So you can buy it, but it goes through a platform. But I'm thinking about making an open source version, so with less feature. But you could use our hardware and run an open source stack on it. And use it without a platform, like for doing TTN mapper stuff, for example. But eventually also make your own firmware for some specific usage. Basically, it's something really easy for me, because the tracker itself is based on another of my project, which is an open source IoT SDK. So basically, all the drivers and all the underlying components like radio communication, secure storage, and so on are already open source. So I just had to make a simple functional code over it. And that could be a purpose for a Kickstarter project. So I'm actually currently trying to see if there is an interest for the community for such a tracker with an open source firmware. And if it is, I think I will start this project on this hardware.
Nice. We have a question by Alma, so just trying to answer on the chat. But what software do you use to simulate LoRa or Sigfox network? I can imagine, no?
When you think about simulation, Alma, you mean a coverage simulation or transmission simulation? I see that Jose has the same question.
Yeah, exactly. Well, let's start with a coverage simulation. Now, for example, I remember that Sigfox gave us these micro-base stations to simulate other bands, no? From
yeah, I mean for simulate the transmission, we don't use a lot of things. In fact, the best thing is not to simulate, but is to use the device to transmit. So it's basically what I'm doing. But we more use software from Sigfox for receiving the signal and decoding it. To verify if the frequency is okay, the bitrate is okay, if the signal envelope is okay, and so on. So at Sigfox, there is RSA tool, which is, I mean, the tool itself is open, it's free, but you need to have a SDR key from Sigfox, the snake, but something like under $100. So that's really good to do some verification on what you are transmitting. But basically, if you are using module, it's really rare you need such things. So in my point of view, as a device maker, the tool I'm using are more SDR key or spectrum analyzer for watching the signal and verify it. VNA for antenna matching. They are basically the tool I'm using the most for development. And for coverage, Sigfox is a public network, so basically we have the maps. So that's good for this. If we deploy other antenna, I think they can have some simulation tool also, but I don't know them. And for LoRaWAN, I don't do simulation. I move around the antenna with a tracker and measure on the field what is the coverage. Jose, maybe you can complete.
No, it's about the same thing. So VNA as a spectrum analyzer is usually what you need for radio side. If you're doing simulations on the cloud side, I guess that's why I asked Alma what was the question. If it's to simulate a device, just so your cloud service, for example, you can test that. There are some tools. I mean, there's Sigfox demo, and for TTN, there are simulation tools on the command line you can use to simulate packets. But yeah, I'm not sure what they meant.
And for this, basically, as they are integrating with the API, so I mean, you can also simulate the backend, the existing network or Sigfox backend just through software that can place some API call. So there's really nothing really specific on this.
Mm-hmm.
Okay, I have a question for Jose, not from the chat, because he already had replied it. But what do you think about Helium? How it competes with TTN?
Helium is an interesting network, so I think the idea is they reward people for having gateways. So TTN, while they have about 12,000 gateways now registered, I believe, many of those gateways aren't actually active. So they're probably just set up once and put it on a drawer or something like that. Or they changed IDs. There's many things that can inflate that number. So we're never sure what the coverage is. So the idea that Helium tried is they will reward you for running the gateway. So keeping it running, you earn this cryptocurrency they have, which eventually will translate into money or credits to send data. And also they reward you for having actual connectivity. So they test this. They send some test packets once in a while, and they see if other neighboring gateways can listen to those packets. And if they do, you win more cryptocurrency. So it's kind of a smart way of encouraging people to run the gateways. And I can see that it can translate into other networks. So one problem with TTN currently is it doesn't roam into many other networks other than CNET. So if you have a node on a commercial network, for example, you can't roam easily from TTN. And it's difficult to encourage those commercial networks to join TTN because there's no reward for them. Why should they do that? So I think with cryptocurrency, you can kind of balance this playing field, and then you can enable roaming this way. So it's interesting. It's a very small network, so I think they have about 4,000 gateways at the moment, mostly in the US and Canada. But yeah, keep an eye on them. I think it's definitely an interesting model and different from others. So yeah.
Yeah, absolutely. We saw a presentation at the IoT Zurich meetup,
Mm-hmm.
I think, and it was truly interesting that they are trying to approach Europe. I don't know if after summer, no? Or
maybe sooner.
Okay. All right, more questions. We still have 34. Okay, we have a question from Jordi. Antenna losses are independent of LoRa Sigfox. What is sometimes convenient is simulate data traffic. So Alma was meant about the analyzing the traffic, the losses, for example.
Mm.
So what do you think?
Yeah, for this point, I mean, when we are doing LPWAN, in terms of traffic simulation, I mean, many people are trying to doing simulation and collision and so on, but on the field, there's no big issue with collision, as in fact, the density of device is low. I mean, if you, I mean, density for Sigfox is 100,000 devices around one antenna, so we are far away. And even if for LoRaWAN the possible density is really lower, the real density and field is really low, so there's no big issue with that. The packet loss, in my point of view, is more related to the white zone or to the movement when you are in Sigfox, because there are a lot of loss when you are moving. And so basically, when you build firmware, that's more, I don't do simulation basically, but what I consider is every time I'm building a firmware, that every packet I want to send will be lost. So it means that when I'm sending a data which is important, I will potentially repeat this data in the next later frames to get more chance to get it, or eventually, as in Sigfox, I know that in movement I will lose data. It means that I will use an accelerometer to ensure that I'm not moving when I'm transmitting. You know that I mean I will manage this traffic loss through a firmware solution more than through a statistical approach, basically. Yeah, that's the way I'm working on this.
Yeah, and with LoRa you have the ADR, so you can use
Yeah.
ADR to manage that and see it from the gateway side.
Yeah, sure. You have a confirmation for this. Yeah.
Mm.
Nice, nice. More questions. No more questions. All right, I think, yeah, we talk about a lot of things, no? We saw a solar TTN gateway, no, on a rooftop. All the details that you built, no? Actually, no, your premise was to have the lower cost possible solar LoRa gateway. That was great. And we also saw Jose's presentation about RAC, about these future WISE blocks, no, that RAC is gonna present very soon. No, if you need anything, I think the email from Jose is here. If not, you will be able to purchase it on the RAC website. I don't know if I forget anything. I don't know if you want to tell whatever you want, Jose, Paul, just to, before saying goodbye.
Yeah, I can start to say thank you, Mark, for inviting us to meet Barcelona. What's a great travel tonight, being with you. So COVID has some certain advantages that we are able to meet foreign people in such events. So thank you so much. And Jose, a word for Jose, if you want someone to make some tests on you know, I'm curious of playing with them.
Yeah. So yes, so from my side as well, thank you for joining. I'm sure the weather in Barcelona is much better than here in Newcastle. But and yeah, I think LPWAN is a really interesting field, and we'll see a lot more in the future. LoRa especially is developing very quickly. So I didn't mention things like LoRa over satellite and different battery chemistries, all sorts of things that are happening now. So it's a very exciting field. So yeah, definitely keep in touch with this IoT meetup in Barcelona, and maybe next time in physical, in person.
Sure, yeah, no, let's keep in touch, because yeah, what you're doing, it's incredible actually. Yeah, to follow Paul, yeah, go to his blog, disk91.com. And with Jose, actually, in a couple of weeks, we are speaking, you and me together at the IoT Zurich, if I'm not wrong.
That's right.
So
yeah.
we will do some interesting secret stuff on LoRa gateways.
Yes. Yes.
So if you are interested on LoRa gateways and how to manage, a lot of LoRa gateways with rack, just go to the IoT Zurich meetup and register for the next meetup. I think it's 29th of June.
Yes.
7 p.m. same time.
Mm-hmm. Be cool.
So people can know more about new stuff on LoRa gateways. So yeah, thanks for speaking. Actually, thanks for accepting my invitation, Jose and Paul, and thanks to all the people that came to the IoT Barcelona meetup. I hope that you like it. I will try to do it monthly now that it's virtual until September or so. So looking forward to see you at the next meetups. And yeah, if you have any questions, just contact me on the meetup, on Twitter, by email. And yes, sure, my contact. Well, yeah, the easiest sometimes it's LinkedIn or Twitter. If not, I leave here my email. So it's simple. The chat it's working. Yeah, so yeah, you can contact me on LinkedIn or Twitter, and yeah, and if you want to speak, just feel free to contact me on Meetup or these channels. And I'm looking forward to talk, to see you all at the next meetups. Good to see you, and yeah, I don't know. Have a good day.
Thank you so much.
Thank you all. Thanks.
Thank you all for listening.
Thank you. Bye-bye.
Bye. All right. Thank you, Jose and Paul.
Thanks, Mark.
We didn't talk about your solar gateway, Jose, but
yeah, it's kind of a
next time. No problem. All right.
It will be on tour in the UK, so there's a guy coming to pick up the prototype from the factory, and he will carry it around. So there will be some kind of posts about it. Yeah, he's taking a van and picking it up. Is Jeff he was UK sales rep for Semtech some years ago.
Okay.
And he's got about 100 gateways deployed under his name. He's a gateway, crazy gateway guy, like a cat lady, but for gateway. Yeah, so he's going to take it around the UK.
Interesting. Yeah, that's cool. Actually, Paul, I had a problem with a YouTube live stream. I realized that I didn't press a button, that it was a very tiny button to